Today we're looking at the paper, A Distributional Approach to Control Text Generation by authors from Cairo University and Navar Labs, Europe. The paper is about control text generation using pre-trained language models. Pre-trained language models such as GPT-2 have some problems because they are generating language in an unconstrained way, meaning that they could be carrying various biases from a training data to the generated outputs, and also they are difficult to control in order to generate outputs that are focusing on a particular topic, such as a particular sentiment. Let's say if you want to generate only outputs that are positive or negative in nature. Because of these limitations of standard pre-trained language models, there has been a number of papers focusing on coming up with ways of constraining language models to make them generate outputs which have certain properties. And one way to do this that has been worked on before in previous work is to use reinforcement learning to constrain the models using some sort of rewards provided by some sort of a standard quality function, such as blue for translation or rouge for automatic text summarization. And you can use this such a policy to fine-tune those language models further to increase rouge scores, for instance. However, this has a challenge, a problem, in the sense that if you use this reinforcement learning, you are typically steering away the language model away from the original distribution learned from the text data, which can lead to learned degeneracy in the outputs, such as having a lot of repetitive tokens, repetitive information, or even producing tokens that are just very frequent in the training data set and might lead to a specific outcome, but might not be very relevant to solve the task. And in this particular paper, the authors propose a so-called distributional approach to this controlled text generation problem. They come up with a optimal way to modify the on the fly this probability distribution of the language model in order to steer it towards a direction to have these constraints. However, at the same time, the steering away is kind of carefully measured such that it doesn't move away too far away from the original probability distribution of the language model, such that you don't get as much degeneracy by forcing these constraints into the language model. The paper is quite theoretical and it contains large sections on this formalization of how they come up with this method. I will not cover this here, but seems to be working quite effective. You modify the distribution and seems to be pretty effective. If I go down to some examples, just to give you a flavor of what is done. Here we have some samples first generated by this GDC method from the paper. And then below you have some outputs generated with reinforcement learning, a few different methods. And first of all, you can find in the reinforcement learning, you're getting a lot of repetition in these examples, like performance here is repeated 3 times, and then quality, and so on. And also the models in yellow here, we have the frequency of the words in the corpus. And it seems that the GTC model is able to generate samples with lower repetition, as well as is able to generate low frequency words as well, while still generating outputs with the target constraint, which in this case is very positive outputs. In the paper, you have some more examples of outputs generated using different constraints. You can take a look in the appendix. And finally, the authors also show that this model is capable of also combining multiple constraints, mixing them into a single constraint. And you can find more details in the paper. In overall, it seems to be a very interesting approach with some robust analysis and proofs in terms of why it's a good way to modify the probability distribution of the language model to steer it towards a particular direction in terms of constraints. And check out the paper for more details, and I will talk to you in the next video. Thanks for watching.